All right. So welcome back. How's everyone doing today? All right. We'll start class out with any questions that you may have. We have a test on Thursday, right? So I do have what some students would consider a review, but I'm not a big fan of reviews because when I give you a review, for some reason, students think that this is what the test is going to be, and I'm just going to change things around a little bit. And so then when they get the test, they get all upset because they're like, well, it was nothing like the review. So I'm not calling this a review. I'm calling this more of like a recap of topics. I'm not married to this thing in the sense that I have to give you a test that is exactly like this, all right? To be prepared for this test, you need to have done your homework, kept up with the lectures, made sure you're understanding all the questions I'm doing in class, practice, and we'll see, right? I'm going to try and make a fair test, all right? I also said I would check your homework today, right, as a quiz grade. I also said I would check that you have your formula sheet. Remember this? I remember.
I thought it was either or.
Is one or the other? So let's start with questions. Are there any questions over any of the problems? Anything that I've done up to this point or anything that you want to talk about? No? Do you all feel ready for this test? Okay, so you want to talk about that? It was 31?
31 on
and 6-1, number 31.
So do you have any additional material to teach today, or is it going to be?
Well, there's nothing that's going to be on the test. Nothing I would do today would be on the test. What I really was hoping we would do is kind of like break out into groups, and then you would start looking at this practice thing that's not a review for the test. And so you kind of get an idea of the scope of what's covered. Because we go all the way back to Chapter 3, Section 5. We go all the way back to that. So I was going to give you maybe the first half hour, 45 minutes to go over this. Or you work through it together. And then maybe spend the last 45 minutes or so with me answering any questions that you ran into on this. So if it's something you look at it, you're like, yeah, I got that, no problem, then go to the ones that are more challenging, try and get those done. That's my plan. All right, but I'm being asked about number 31, which was a kind of a bonus sort of issue, problem, yeah?
The 6.1 homework.
This is 6.1 homework. Okay, use reduction formula. So it's saying to use a reduction formula from example 6 in the book to show that this integral is this. So use the reduction formula from example 6. So if you flip back to example 6, is the reduction formula. And we actually did that in class, didn't we? So using the formula, do I need to write the formula out on the board again? It's right here on page 315. It's formula number 7. So according to the formula, if this is an n, if our n right here is 2, then the formula says what? Negative 1 over n, so we would have what? Right, hold on. Negative 1 over n. So for us it would be negative 1 over 2. And then the formula says cosine x sine to the n minus 1. So what would that be? Sine, just sine to the first power, plus n minus 1, which would be 1 over, you did as a bonus. Anyone else do it as a bonus that want to turn it in? Where else? Now integral sine to the n minus 2. What would n minus 2 be here? 0? Now what is sine to the 0 power? 1. So this is really just a 1. Right? Anything to the 0 is 1. Well, except 0 to the 0, but that's a different scenario. So this right here, this whole thing should be a 1, which means what is the integral of 1 dx? Just x. Just x, right? So this becomes negative 1/2 cosine x sine x plus 1/2. We said the antiderivative of 1 with respect to x was x plus some constant. And I'm trying to get it to look like this, right? Do we agree? So how am I going to do that? Do I have this already? Right? That's this, right? So all I need to show is that this is equal to this. Are these two the same thing? Okay, there would be if there was a 2 in front of this. So let me write that down right up here. Negative 1/2 is sitting out there. You said that this right here, if it had a 2 in front of it, it would be sine 2x, wouldn't it? So I'm going to put a 2 in front of it. Can I rearrange it? Sine x, cosine x, is that all right? But I can't just put a 2 in front of it, right? What else would I have to do if I put a 2 here? I'd have to put a 1/2 in front of that. Isn't that the same? Isn't half of 2 1? And so I haven't really changed the problem. But what's this right here? Double angle, that's sine 2x. And then what's this right here? Negative 1/4. And so that's this. Isn't it? So it is the same thing. Did you get it to this point?
I got it to that point, and it was just like, I don't know, I struggled on that, so I was like, well, maybe I can change the integral sign into like the 1 minus cosine, all that stuff
Yeah.
over 2, and I was like, that's not.
They just wanted a direct replacement. You could have maybe done this and said, hey, look, I know that this is what? 2 sine x cosine x? And then the 2 in this would be that? And that matched exactly what you had here. So anytime you see sine x, cosine x next to each other, be thinking double angle.
It's one of those hidden ones.
It's kind of like a hidden one a little bit there. All right, that was part A. Do I need to talk about B, or is part B to prove it?
Part B was like basically taking the same thing, but with the sign to the fourth.
Okay, so
Yeah, that was okay.
that one was all right?
Yeah, number 2,
Okay.
or sign to whatever. Don't worry about that.
Anything else?
It's
Yes.
question number 13 from the homework.
13? Question 13. E to the 2 theta sine 3 theta d theta. So what happened? What was wrong? Did I mess that one up on the video or something? Oh, okay. E to the 2 theta sine, not this one? Oh.
6.2.
Oh, 6.2. I'm sorry. Oh, that one had a tangent in it. Okay, so that probably, you probably didn't like that, did you? Okay, so it was cosine squared x, tangent cubed. So I said on the test that there would be possibly a bonus, right? And I said that it would be most likely in the form of a reduction formula, right? If there was a bonus. This right here would be a candidate for what's on the test, because we did talk about this last time. As long as it works out. I haven't worked it out yet. Let's see what happens. So the only thing we really know how to deal with at this point is sine and cosine. So maybe I should turn everything into sine and cosine first. This is cosine squared x. Tangent cubed is the same as what? Sine cubed x over cosine cubed x dx. Yeah? And we get some cosines to cancel there, don't we? Could cancel out, maybe. I would be left with what? One cosine on the bottom? So this would become integral sine cubed x over cosine x dx. It's a good problem. Now what? Did anyone get this, or anyone got stumped there? Okay, so here's a little reminder, some advice. Just because you are in Chapter 6, Section 2, does not necessarily mean you have to use the methods from Chapter 6, Section 2. So anything that you've done up to this point is fair game. So if you do that and you take a step back, U sub, what would you use as your U? Cosine? Because the derivative of that is negative sine and it appears up here? But you'd have to peel one off, wouldn't you? So let me peel one off first. Now I could make that U substitution. U is cosine x. The derivative of it is negative sine x, which is here. I'm off by a negative. But how are you going to deal with sine squared?
Oh, use that reduction. Or can you
Can't do the... you might be able to do integration by parts, but we're trying U sub right now. Why not turn it into 1 minus cosine squared? Right? Wouldn't that just turn into then 1 minus... Remember what U is going to be here. Let's write that down. U is going to be cosine x, right? The derivative of that is negative sine x dx, which I can make it positive by just what? Changing that to a plus, changing that to a minus. So I'll be able to deal with that. But then sine squared, just so y'all are clear, you never square both sides here and say that sine squared dx, right, that whole thing squared is du squared. You don't mess with that. But I can get sine in terms of cosine using the Pythagorean identity. So if I rewrite this problem as what integral this sine squared turns into 1 minus cosine squared, right, x over cosine x, and then sine x dx, right? That's where I am. Then at this point, making the substitution, this integral turns into, okay, 1 minus cosine squared turns into what? 1 minus u squared. And cosine on the bottom turns into u, and then sine x dx turns into negative du. So how about the minus out here and the du right there? And what can you do with that? You can just split it up, right? You have two terms on the top, one term on the bottom. You can split that into two integrals. So we'll have negative integral 1 over u minus u squared over u du, like that. Which is negative integral 1 over u minus u du. And these two can be integrated, right? Antiderivative of 1 over u, natural log of the absolute value of u, antiderivative of u, 1/2 u squared. So we'll have negative natural log absolute value of u, antiderivative of this, right? You have a negative, but then the negative again, right? So what, plus 1/2 u squared plus some constant. Understand? But what was u? Cosine x. So this should be my final answer. Should be negative natural log cosine x, and then plus 1/2 cosine squared x plus c. And this was number 13, so I doubt that's the way it appears in the back of the book.
No, that's the.
That is the way it appears? Okay. I thought for sure they were going to take this negative and bring it up as an exponent and then make that 1 over cosine and turn it into secant.
They had both the answers.
They had both? Okay.
Yeah, whether it's secant or.
Secant inside the natural log instead?
Positive.
Yeah, so that's one thing you could do. I'm just pointing this out. Is that the negative power would come up like a -1 and cosine to the -1. Not inverse cosine. Cosine raised to the -1 power is the same as 1 over cosine secant. So if you see this answer in the back of the book, that's where it's coming from. But that would be fine. That's it. So you don't need that technique necessarily. Now, it's not to say it couldn't be done. It might work, but this basic U sub worked just as well. And I think I alluded to this a while back. I said, you know, this first test is actually going to be relatively easy in the sense that we really only have power rule, basic substitution, integration by parts, and then a little bit of this trig stuff, which we didn't use here, but 6.2. So we really only have a little bit. There's still trig substitution, partial fraction decomposition. Those two are really tough. Yes?
Is he going to be labeled for which one to use it?
No. Integrals in general will always, I mean, like in an engineering class, if you come across an integral, it's not going to say use this method. So what we want to get good at is just looking at an integral and knowing, you know, we can attack it different ways without being prompted on how to use it or how to attack it. But that's what I'm saying. The good news is that we still only have a narrow focus on what we can use. The next test that we have, all the techniques will be on the table. And so there's really no, you just have to be really comfortable with all of the different methods. Yeah. Yes?
Could we take the non-review review home?
Oh, yeah, you can have this. Yes. This is really just a guide. It's just, I was just trying to get a layout of like what types of problems we had done. And I actually took these problems from my internet students who's supposed to be watching this video. And this is just, I took a bunch of problems out of their homework sets and came up with like a review. So. Don't know. I don't know. I'll have to see. That's why I wanted you to work on this for the first half hour, 45 minutes, and then towards the end I can address any questions that you still might have on these. All right, are there any other problems you want me to do? Right now? I'll do more at the end when you've looked at this. Okay, let's go ahead and pass this out. Let's see. There we go. Go. Should be it. Okay, so remember, big asterisks here. I did not just hand you the review for the exam, right? Okay, I handed you some problems to take a look at. And so let's spend the next, wow, it's already 1:20. Let's spend the next half hour. Maybe we'll go till 2. Let's see how how it goes for you. And then I'll stop you at some point and I'll say, okay, who has a question over which one? All right? I do think that the length of this exam would be indicative of the length of your exam. I mean, I think it might be a little long. I would think maybe 20 problems tops. This is 24. So part of this is something I've also told you about. It's not just can you actually find, these antiderivatives, it's can you do them quickly. Does it take you half an hour to finally say, oh, that was just a basic U substitution, after you attacked it with all these other things like integration by parts and that only comes with practice. The more problems you've done, the quicker that is. And so that's part of what you're being tested on, is how fast you can get to these results. So work through these, help each other out, ask questions, raise your hand, I'll come by and kind of nudge you in the right direction. All right? I'm going to kill this video and then we'll bring back the second video later.